Welcome to VMware vFabric Reference Architecture, a joint collaboration project across vFabric engineering, field, and global technology services teams at VMware. In this presentation, we will take a look at a high-level overview of the vFabric Reference Architecture, then take a deeper dive into the 15 technology topics within the vFabric Reference Architecture. VMware vFabric Reference Architecture Overview. First, we start with the definition of reference architecture. Reference architecture is a software architecture where the structures, respective elements, and relations provide templates for concrete architectures in a particular domain or in a family of software systems. You can think of it as an architecture blueprint that you can refer to, or an architecture on which to base another architecture. In the vFabric reference architecture, we help you to find answers to the following questions. What is vFabric? How are the components integrated? To which enterprise implementation patterns does it apply to? How can it simplify custom applications in such a way that it reduces cost and complexity? And what is the process on which you would have to follow in order to migrate a JEE legacy application to the vFabric reference architecture? Let's take a look at a high-level diagram of the components used in the vFabric reference architecture. First, we used Spring Tool Suite, Spring Data, Spring Integration Patterns, Spring Batch, and collectively this formed our application development framework. In addition to the application development framework, we leverage vFabric runtime components such as the Java runtime TC Server, Web Server, EM4J, RabbitMQ for messaging, SQLfire, Data Fabric, Gemfire, and then Postgres. In addition to this, we also used vFabric Application Director, Data Director, and vCenter Orchestrator. Collectively, this formed our application deployment strategy. We also added holistic monitoring by leveraging vFabric APM, Hyperic, and vCenter Operations Manager. So what motivated us to put the vFabric reference architecture together? In the past several years, we have noticed a set of challenges that our customers are having with their JEE custom applications. We took those challenges and mapped them to solutions within the vFabric reference architecture. Let's examine those challenges and solutions. First, building modern architectures that are of dynamically changing business requirements is always challenging. In the vFabric reference architecture, we use the Spring Trader application that has several layers of configuration across the data, user interface, and messaging layers. Building scalable applications is always a challenge. In vFabric reference architecture, we put the Spring Trader application through its paces in our lab environments. The data generated will help guide designers to size a platform correctly for their own Spring Trader workload. In every architecture, there is a concern about moving data from one data store to another. In vFabric reference architecture, we demonstrate how to leverage a load balancer layer across Spring Batch horizontal scalable mechanism. Explosive data growth is a challenge many of our customers are having, and they've often engaged us to provide them with solutions that move the data closer to the application in order to provide better horizontal scalability and faster response times. In vFabric reference architecture, we leverage vFabric SQLfire to manage a memory-oriented but yet disk-persistent data management platform. Setting up development environments predictably and quickly is always a challenge. In the vFabric reference architecture, we fully automated the development environment setup for Linux, Windows, Mac, and OVF for virtual environments. In a matter of minutes, you could be up and running with your development environment. Setting up production environments is always error-prone and time-consuming. In vFabric reference architecture, we provide set of deployment scripts, deployment through Application Director, and other release management automation techniques to help you with quickly deploying vFabric reference architecture in production environments. Holistic monitoring of infrastructure and application components is always a challenge. In vFabric Reference Architecture, we use vFabric APM and vCenter Operations Manager to provide comprehensive monitoring of software components and infrastructure components. Setting up distributed active-active architectures is always a challenge to be able to administer both reliably and predictably. In vFabric Reference Architecture, we demonstrate a global multi-site active-active architecture by leveraging vFabric SQL WAN gateway. And lastly, mindshare is always a problem. Having a fully documented technology stack for your reference architecture is always a challenge. In vFabric Reference Architecture, we've documented the entire stack by providing instructional videos, source code examples, and scripts for deeper automation. The vFabric Reference Architecture is divided into 15 architectural topics of concern. Topic 1 is an overview topic of the entire architecture. Topic 2 is about migrating a legacy JEE application to the vFabric Reference Architecture. Topic 3 is capacity planning and sizing. This is where we've put SpringTrader through its paces in our lab environments. Topic 4 is to do with development environment setup. Fully automated scripts can help you set up your development environment in a matter of minutes. Topic 5 is about setting up production environments predictably by following YouTube videos on the setup. Topic 6 on holistic monitoring. Topic 7 is on distributed active-active architectures that leverage vFabric SQL WAN gateway. Topic 8 is about automated deployment using vFabric Application Director. Topic 9 is on release management. Topic 10 is a set of instructional videos. Topic 11 is data modernization and data movement, showing how you can move data between two Postgres instances in a horizontally scalable manner by leveraging Spring Batch and a load balancer layer. Topic 12 is data modernization through fast data design patterns that are implemented in vFabric SQL. Topic 13 is SpringTrader reference application architecture, a deep dive into the internals of SpringTrader. Topic 14 is on SpringTrader mobile. And last but not least, topic 15 is on lightweight service orchestration framework using vFabric Reference Architecture. The 15 topics presented so far can be found at the below URL. You can visit this URL for further information. In fact, vFabric Reference Architecture IP set can be used by the following. Architects can use the entire set to design their greenfield projects, or projects that require a certain section of the architecture enhanced. Developers can use the topics on the left-hand side, and ops admins and DevOps engineers can use the topics on the right. It's worthwhile noting the vFabric Reference Architecture has been built on proven customer use cases. Each of the 15 topics are representative of the most common customer implementation. In fact, greenfield projects that can be built from the ground up using modern concepts can leverage the vFabric Reference Architecture entire set. Projects that are about migrating JEE-based applications to the vFabric Reference Architecture can leverage Topic 2 information, showcasing how Spring Migration Analyzer can be used to quickly analyze the codebase. If you're not ready for a complete greenfield project, but wish to modernize a certain section of your architecture, for example, the data tier, you can also leverage any of the individual topics within the vFabric Reference Architecture. The vFabric Reference Architecture can be used for automating application deployment through vFabric Application Director, extensive monitoring through vFabric APM, data modernization and scalable batch mechanism through leveraging a load balancer layer and Spring Batch, data modernization for fast data patterns using vFabric SQL, building highly fault-tolerant data platforms and messaging platforms, and also geographically distributed fault-tolerant active-active architectures. Let's take a pause for a minute and acknowledge the vFabric reference architecture team, and also discuss the development methodology applied in this project. The vFabric reference architecture was built using an agile methodology. vFabric reference architecture is vetted across a wide group of engineers: vFabric Engineering, GTS, vFabric SE, and PSO communities. Also, we want to thank our stakeholders and sponsors: Chris Birtwistle, Dino, Matt Quinlan, Chris Keen, Kevin Murley, Paul Rock, Raj Ramanujam, Matt Stepansky, and Todd Surdy. Also want to thank our technical leads, Brian Dassault and Emad Benjamin. Each of the topic owners are shown here: Brian Dassault and Emad Benjamin on topic 1 for the overview of modern architecture, Abdul on topic 2, Hal Rosenberg on topic 3, Jeremy Kunash on topic 4, Edgar Honing on topic 9 and 13, Channing Benson on topic 5, Mahesh Rajani on topic 7 and 8, Timo Sigilyani on topic 6, Kevin Lees, reviewer on topic 6, Jeff Holmes on topic 10, Jeff Holmes again and Wayne Lund on topic 11, Guillermo Tantachuco on topic 12, Jay Marshall on topic 14, and last but not least, Chris DeLashmit on topic 15. For the vFabric reference architecture, our Scrum Masters are Monty Kingstone and Donna Colburn. Marketing, Mary Elston, Neera Metcalf, Al Sargent, and Ankar Agarwal. The project was run essentially in an open source format. Anyone with a great idea was welcome to contribute. The idea was to have a direct connection from engineering all the way to customer via our SE and PSO organizations, where a continuous stream of customer feedback is implemented into the vFabric reference architecture. We want to thank the entire vFabric reference architecture team for their dedication to this project. vFabric reference architecture deep dive. Topic 1, Overview. Shown here is a high-level component architecture diagram of the components used within the vFabric reference architecture. First, we started with Spring Tool Suite, Spring Data, Spring Integration Patterns, and Spring Batch. Collectively, this made up our development framework. We also leveraged the vFabric runtime components, such as vFabric TC Server, Web Server, EM4J, RabbitMQ, SQL for in-memory data fabric, Gemfire, and Postgres. We also leveraged vFabric Application Director, Data Director, and vCenter Orchestrator. Collectively, this made up our application deployment strategy. And then we added holistic monitoring through vFabric APM, Hyperic, and vCenter Operations Manager. So how did we get started? First, we took the DayTrader application, which is a JEE-based Java application, and analyzed it using the Spring Migration Analyzer tool. The Spring Migration Analyzer tool is a tool that gives you hints about how to refactor your application code base away from EJB constructs, and in favor of a simple POJO pattern. This diagram shows the Spring Trader high-level architecture. The presentation layer was built using jQuery, Bootstrap, and Backbone, while the UI communication to the server side are based on REST and JSON. The backend layer, on the other hand, is made up of application services, message broker integration services, and a data tier. The application services are essentially built using a Spring Framework, Spring Integration, Spring Data, and Spring Security, while the messaging system is based on RabbitMQ and AMQP protocol. The application leverages messaging to submit buy and sell orders from SpringTrader asynchronously via integration services back to the vFabric SQL file, while the remainder of the SpringTrader application services transactions apply a synchronous change pattern that are communicated directly to the vFabric SQL file data fabric. Let's take a closer look at the data tier. The data tier uses vFabric client server topology. This is one of the most commonly used vFabric SQL file deployment methods. At the client tier, essentially the application tier, we have two kinds of application services. Those known as SpringTrader integration services and then SpringTrader application services. Shown in the diagram are one SpringTrader integration service and three application services as application service 2, 3, and 4. The client tier communicates back to the vFabric SQL file data fabric. The data fabric in turn, in this case, has 4 SQL file data members, shown as SQL file members 1, 2, 3, and 4. The SpringTrader data is partitioned across these 4 SQL file members, which are essentially JVM processes. This helps you build a horizontally scalable data fabric, where if more data is required to be managed in the future, then you simply add additional SQL file data members. While the vFabric SQL file is in-memory redundant and disk persistent, additionally, we write certain transactions back to vPostgres via the DB Synchronizer plugin, and then horizontally scalable Spring Batch mechanism copies the data to a secondary vPostgres database. In this pattern, we are simulating how some of the daily transactional fast data needs to live in memory while also persistent and redundant. On the other hand, slower acting data can be moved to slower data stores via DB Synchronizer plugin for downstream backend business processes that are less critical. Let's take a closer look at the SpringTrader schema. The account table is made persistent, has one redundant copy, and is a partitioned table by the primary key, i.e. the account ID. By partitioned, we essentially mean that if 100 records exist in the account table, now since we have 4 SQL file members, each SQL file member will get 25 records. Now the account profile table is configured to be replicated, meaning every SQL file member will get a copy of this table. We can do this because there are a very small number of changes to the account profile when compared to the number of changes in the account, orders, and holdings tables, for example. This is why account, orders, and holdings tables are partitioned instead. The holdings table has a redundant copy. It is also persistent and partitioned by the account ID. It is also co-located with the account partition. The reason why we co-locate holdings table with the account partition is because of the access patterns from the SpringTrader application that often has SQL joins across the account and the holdings table via the account ID. The quote table is simple lookup table, and hence it is replicated on every SQL file member. The table doesn't change that often. The orders table has one redundant copy. It is persistent, again partitioned by the account ID and co-located with the account partition, for the same reasons that the holdings table was co-located with the account table. The global multi-site topology is an extended version of the client-server topology we saw earlier. Essentially, at a local data center, there is a local client-server topology that is connected across the WAN to the other client-server topologies via the SQL file WAN gateway process. One of the key distinguishing features of vFabric SQL file is the WAN gateway. For fault tolerance, there are 2 WAN gateways, a primary and a secondary path. Topic 2, JEE Migration to vFabric Reference Architecture using Spring Migration Analyzer tool. In Topic 2, we look at how one can migrate a JEE application to the vFabric Reference Architecture. As mentioned earlier, we essentially simulated this by taking the DayTrader application and transformed it to Spring Trader. The key in all of this migration activity is, of course, the Spring Migration Analyzer tool. We have created a step-by-step migration video that you can reference here. You can also download the Migration SMA tool from the following GitHub location. A quick migration step is to run the migration-analysis script against the EAR file of your application to generate a refactoring set of Java doc reports. So what are some of the things to consider when migrating code? No code changes are required to migrate JDBC data source transactions. You can leverage Spring JDBC Transaction Management. For JMS, you can leverage the Spring JMS support, and similarly for JNDI, you can leverage Spring JNDI lookup support. For JTA transactions, ideally you want to refactor code away from JTA by using local transaction support and direct transactions. For cases where this is not possible, you can leverage plugins such as Atomicos to behave as the distributed transaction manager for JDBC and JMS type of transactions. Let's look at an impact analysis of DayTrader versus a non-JEE approach. DayTrader uses JMS API. Now typically little or no migration is required, as JMS can be used within TC Server. Consider using Spring JMS template. DayTrader also uses JNDI API. Now, JNDI is available in TC Server and therefore no work is required to migrate the application. It may be worthwhile considering using the JNDI support within Spring. DayTrader also utilizes the JTA API. Now, ideally, we want you to refactor code away from JTA by using a local transaction support and direct transactions. For cases where this is not possible, you can leverage plugins such as Atomicos to behave as a distributed transaction manager for JDBC and JMS type of transactions. Let's look at a further impact analysis report of DayTrader versus non-JEE approach. DayTrader uses many classes for data source transactions. Now typically no code changes are required. However, during the migration you may want to consider using JDBC template and transaction management to simplify your code base. This is readily available in Spring Framework. DayTrader also uses stateless session beans. Stateless session beans can be easily migrated to Spring Core Framework. DayTrader uses message-driven beans. Now, assuming that an external JMS provider is available, the migration of each MDB is straightforward. Such beans are usually migrated to a Spring message-driven POJO facilitated by a message listener container. Message-driven beans that use declarative JTA transactions, often that's the default configuration, which is not necessary. Now, if the transaction upon inspection does not involve any external resources, then the transaction was not actually necessary and you can refactor that out of the code. The bean can be easily migrated to a Spring message-driven POJO with no declarative transaction configurations necessary. vFabric Reference Architecture Topic 3, Capacity Planning and Sizing. In this topic, the Spring Trader application was put through extensive load testing. The idea is to showcase how you can potentially size your own platform based on the performance data presented in this topic. The extensive results can be found here under Topic 3 of the vFabric Reference Architecture main page. The topology used is based on the vFabric SQL Fire client server. The application tier shown here has 2 Spring Trader integration services and 4 Spring Trader application services. The key difference between integration services and application services is the way they communicate with the back-end services. Application services are essentially Spring Trader instances that access partition data from the vFabric SQL Fire data fabric, more or less in a synchronous fashion. Also shown is the data fabric, which is made of 2 SQL Fire members for this particular test. But particularly in a production environment, you would have more SQL Fire members. In this case, great performance was achieved with just 2 SQL Fire members. On the other hand, the Spring Trader integration services submit buy and sell orders through an asynchronous pattern via Spring Integration and RabbitMQ. Let's take a look at the performance results. The following chart shows the number of application services VMs on the horizontal axis, number of users on the left vertical axis, and the right vertical axis shows the scaling from one application services VM. Highlighted here is the result from the case of using 4 application services VMs. These application services VMs are shown here in the application tier, representing 4 Spring Trader application services, communicating back with the Spring Trader data fabric tier. The results were quite impressive. For only 4 application services Spring Trader instances, we were able to achieve 10,400 user sessions. Roughly speaking, these translate to about 3,000 transactions per second. The response time was equally impressive. For that many users, the approximate response time was 0.25 seconds. Again, a great result for a minimal amount of compute resource utilized. vFabric Reference Architecture, Topic 4, Development Environment Setup. In this topic, a set of automated scripts will help you build your complete vFabric Reference Architecture development environment in a matter of minutes. Specialized scripts for Windows, Linux, and Mac have been provided. There is also an OVF template for building out a complete VM that represents the entire vFabric Reference Architecture development environment. To get started, go to the vFabric Reference Architecture Topic 4 in the below URL. But here's a quick summary of the development process. First, you download from GitHub the vFabric Reference Architecture archive. Unzip this and get started. Then you download vFabric SQL Fire and Gemfire from My VMware. Next, you bring up a terminal depending on your OS that you're using. And then you run a simple ant command, ant fetch all, and ant devenv to build the entire application stack of the vFabric Reference Architecture. At the end of the execution of the ant script, you will have an entire development environment and the ability to click through Spring Trader. vFabric Reference Architecture Topic 5, Production Environment Setup. Thus far, we have seen how using Topic 4 you can build your development environment relatively quickly. In Topic 5, we extend this by providing step-by-step instructional videos for installing the vFabric Reference Architecture in a production environment. Shown here is a list of videos that we provide. For example, installing vFabric Web Server, Hyperic Agent, Hyperic Server, vFabric TC Server, vFabric SQL Fire, installing vFabric RabbitMQ, how to add vFabric Yum repositories, installing vFabric Postgres, and installing and configuring Spring Trader for production. Here is the URL to the YouTube playlist for the entire video set. Production Environment Installation Guide can be found on the vFabric Reference Architecture main page under Topic 5. vFabric Reference Architecture, Topic 6, Monitoring. Holistic monitoring using vFabric APM, Hyperic, and vCenter Operations Manager is used. Self-learning analytics enable a much higher degree of automation than traditional management tools. An integrated approach to performance, capacity, and configuration management. It helps you manage the environment holistically and unifies teams across infrastructure and operations. Using Hyperic, you can gather real-time data, send it to vCenter Operations Manager for further analytics and dashboarding. For further drill down into the code base and potentially offending Java code, you can do further drill down using vFabric APM as shown here. vFabric Reference Architecture. Topic 7. Active-Active Architecture. Here we've divided the architecture into 6 layers of concern. The load balancer layer, the enterprise application layer, messaging layer, data layer, virtualization layer, and the infrastructure layer. Let's double click on each one of these layers. The load balancer layer. Here the load balancer layer uses a combination of a global load balancer and a local load balancer. The global load balancer provides traffic marshalling to geographically dispersed sites by essentially distributing traffic to the local load balancers that are within the data center of the local site. Global load balancers and local load balancers are configured in a highly available HA pair for additional redundancy. Enterprise application layer. This is where enterprise applications are deployed. The layer is configured in such way that within each data center there are essentially 2 independent instances for each software components. Essentially, the application cluster spans multiple infrastructure clusters. In this manner, if an entire infrastructure cluster was to become unavailable, the application will continue to function due to the application components residing in the second infrastructure cluster. In VMware terminology, an infrastructure cluster is essentially a vSphere cluster. Messaging layer. The messaging layer within each data center is highly fault tolerant through various queues, durability mechanisms, and availability mechanisms. There are several methods to provide high availability of nodes by clustering using federation and shovel configuration. Additionally, at the queue layer, highly available and mirrored queues may be implemented. Choosing the right solution for the use case is very important for performance. The data layer. In the data layer, we leverage vFabric SQL, which is a fault-tolerant data management system that is WAN capable. In vFabric reference architecture, the data layer represents 2 classes of data. One is fast data, represented via vFabric SQL Data Fabric, and the other is archival data, stored in vFabric vPostgres Relational Database Management System. The vFabric SQL data layer must be configured in a dedicated vSphere cluster, since fast data is a latency-sensitive workload. And tuning vSphere cluster specifically for this type of workload may hurt other workloads that are not latency-sensitive. In terms of active-active resiliency, vFabric SQL provides multiple layers of redundancy and persistence to guarantee data reliability. The virtualization layer. VMware vSphere provides many resiliency features that help deliver robust active-active architectures. One of the key constructs used are multiple vSphere clusters, making sure that if for some reason a vSphere host fails or an entire cluster fails, a second vSphere cluster is active and available to service traffic to the application. Infrastructure layer. Well-architected systems should not have a single point of failure, but we do understand it is not always feasible. Since we are using multiple layers of fault tolerance, such as the global load balancer, the local load balancer, multiple enterprise application instances spread across vSphere clusters, and a fault-tolerant data layer across WAN configuration, it is assumed that some hardware will fail and the active-active system will continue to function. Global load balancers stacked on local load balancers are shown in this diagram. Each data center has SpringTrader application services distributed across Active 1A and Active 1B clusters. If Active 1A has a complete cluster failure, then Active 1B is available. SQLFire WAN Gateway is used to replicate data across data centers. The entire active-active architecture is shown here. The topology is based on vFabric SQLFire Global Multi-Site WAN configuration, in combination with a global load balancer and a set of local load balancers. Based on the geography of where the application request was originated, the global load balancer will send it to the appropriate local load balancer. For example, New York traffic will go to the New York local load balancer, where there is a load balancer pool configuration containing multiple SpringTrader application services instances. These in turn will communicate with the local data fabric, and certain data changes will then be selected to be replicated to Tokyo and/or London via the SQLFire WAN gateway. vFabric Reference Architecture, Topic 8, Automated Deployment with vFabric Application Director. In vFabric Reference Architecture, vFabric Application Director allows you to build deployment blueprints that automate the deployment of the compute resources and the software components. vFabric Application Director has a unique model-driven, open, and extensible architecture. With its catalog of standard components or services, vFabric Application Director simplifies and automates deployments of multi-tier enterprise applications in the hybrid cloud environment. Enterprise users can quickly standardize, deploy, and configure and scale their complex applications in a dynamic cloud environment. These applications range from simple web applications to complex custom and packaged applications. Application architects can use the drag-and-drop canvas to create visual application blueprints. These blueprints standardize the structure of the application, including software components, dependencies, and configurations. For repeated deployments, with a pre-populated extensible catalog of standard virtual machine templates, application infrastructure components, and scripts, architects can create a blueprint in a matter of minutes. Application blueprints are portable across deployment environments. After a blueprint is available, application deployment, QA, and release management teams can share these. Teams can repeatedly deploy a standard blueprint, customize it as and when needed. In the vFabric Reference Architecture, we have a complete blueprint for the entire stack of the application. For further details on the blueprint, visit topic number 8 on the main page of the vFabric Reference Architecture. vFabric Reference Architecture, Topic 9, Release Management. Release management aims to achieve a runtime environment and application functionality set with a well-known behavioral properties. To implement release management across the stack of technologies used by a cloud-centric application such as SpringTrader, specific infrastructure and tooling is required. The architectural overview slide here highlights key architectural areas and components that support release management. For example, change tracking. Change tracking is the initiation of changes to control deployments such as QA and production environments that require tooling that implements comprehensive change management features. Next is Artifact Repository. The Artifact Repository, or depot, is the gateway for introducing released components into the release management controlled environments. And the next is Release Management Orchestration. Release management orchestration requires a coordinated set of operations to be carried out on the target stack. This requires orchestration of workflow as well as the enforcement of security constraints where their other preconditions are met, and maintaining an audit trail on the workflow execution. Further, release management automation, where actual deployment execution plans are embodied in constructs such as those provided by the SimStack components such as vFabric Application Director, VMware vFabric Data Director, and vCloud Director. Specific sequences of operations can be coordinated with components in the target stack to successfully perform specific deployment and release use cases. And then monitoring is essential for feedback on actual behavior from the managed or target environment to maintain the validity of a deployment and safeguard against losing the quality of SLAs. Events emitted from the monitoring stack can be consumed by the release management infrastructure tooling to signal the need to release managers and operations staff to take action. And finally, the target stack, each deployable component that is subject to a targeted release management and the vFabric reference architecture has specific behavior aspects to consider when performing release operations, as initiated by the release management automation components. Each of the layers of the vFabric reference architecture, for example, load balance layer, enterprise application layer, messaging, data layer, and virtualization layers, has specific instructions on how to best do release management. For the SpringTrader ecosystem to lend itself to release management, specific steps in the development process used to construct and maintain the code base play a key role here. This slide depicts the sequence of events involved in the introduction of changes to a release managed product artifacts, starting with the creation of a change request and ending with the ultimately promotion of the finished deployable artifact. To support this process, several key infrastructural systems are featured. For example, change tracking system, bug report or change request information and tracking information reside here. The system is used to gatekeep actual development efforts, avoiding unauthorized introduction of changes. The next component is source repository. This repository provides the means for developers to share code and build artifacts in a controlled manner, and acts as the system of record for these artifacts prior to release. The next component is build engine. The build engine provides the means to which consistently execute all building and consecutive testing activities that safeguard the quality of the final deployable product artifacts. And then finally, artifact repository. It stores the completed promoted artifact ready for consumption by the orchestration engine and automation infrastructure in order to introduce these artifacts into the managed environments. vFabric Reference Architecture, Topic 10, Video Demos. We have assembled together a vFabric Reference Architecture YouTube list of a set of instructional videos that show you step-by-step installations and design and architecture instructions. Please visit the below URL for further details. vFabric Reference Architecture, Topic 11, Data Modernization, Data Movement. In engaging with our customer base, we are seeing data usage patterns across structured and unstructured data at fast speeds and large scales. A new breed of data ecosystem in the enterprise is quickly emerging. The challenges associated with modern data processing architectures, fueled by the massive growth of unstructured data and the new breed of real-time and big data applications that support analytical workflows, is driving a lot of this. Frameworks like Spring Batch, Spring Integration, as well as off-the-shelf ETL tools are needed to solve the integration problems of moving data streams to real-time and big data applications. Products like vFabric SQLfire and Gemfire support building real-time transactional applications that scale beyond the capabilities of traditional database systems and provide precision to big data analytics. Big data analytics are based on MapReduce and Hadoop frameworks, and supported technologies such as Serengeti, Spring Data for Hadoop, and interactive tools such as Greenplum and Cetus can help our customers solve their day-to-day big data and fast data problems. Here we illustrate how data flows through the various components of the simple ETL solution that we're showing. The SpringTrader application stores order data in the SQLfire data tier. The data tier is asynchronously copied by SQLfire DB Synchronizer to vPostgres staging database. Then one or more worker processes associated with the Spring Batch copy orders job will then copy the order data to the vPostgres reporting database, where it is retrieved by the reporting UI for further analytics. The order data is partitioned among the worker processes to enable scaling of the job across the TC server clusters. vFabric Reference Architecture, Topic 12, Data Modernization, Fast Data through vFabric SQLfire. Let's take a closer look at the data tier. The data tier uses vFabric client server topology. This is one of the most commonly used vFabric SQLfire deployment methods. At the client tier, essentially the application tier, we have two kinds of application services. Those known as SpringTrader Integration Services and then SpringTrader Application Services. Shown in the diagram are one SpringTrader Integration Service and three application services as Application Service 2, 3, and 4. The client tier communicates back to the vFabric SQLfire data fabric. The data fabric in turn, in this case, has 4 SQLfire data members, shown as SQLfire members 1, 2, 3, and 4. The SpringTrader data is partitioned across these 4 SQLfire members, which are essentially JVM processes. This helps you build a horizontally scalable data fabric, where if more data is required to be managed in the future, then you simply add additional SQLfire data members. While the vFabric SQLfire is in-memory redundant and disk persistent, additionally we write certain transactions back to vPostgres via the DB Synchronizer plugin, and then horizontally scalable Spring Batch mechanism copies the data to a secondary vPostgres database. In this pattern, we are simulating how some of the daily transactional fast data needs to live in memory while also persistent and redundant. On the other hand, slower acting data can be moved to slower data stores via DB Synchronizer plugin for downstream backend business processes that are less critical. vFabric Reference Architecture, Topic 13, SpringTrader Application Architecture Deep Dive. The SpringTrader application is made up of 5 major layers. First, the presentation layer, leveraging HTML5, jQuery, Backbone, and Bootstrap. The second layer is the application services layer. This leverages Spring Integration, Gemfire, Spring Data JPA, Spring Security, and Spring MVC. The application services runs inside TC Server. The presentation layer uses a vFabric web server using REST and JSON to communicate back to the application services. The application services in turn communicate to layer 3 and 5. Layer 3 is the message broker through RabbitMQ. Then RabbitMQ integrates with integration services such as Spring Integration, and Spring Data JPA, being leveraged for buy and sell orders to implement an asynchronous pattern. On the other hand, other application services communicate to the data tier, shown as layer number 5. The data tier is essentially, as mentioned earlier, a vFabric SQL file partitioned in-memory data management system. This is a high-level summary of all of the libraries and components used within SpringTrader. Here we see a functional overview of the services involved in SpringTrader application. SpringTrader's application services design approach follows a model in which the use of standardized Spring Framework and Spring Web MVC constructs play a major role. For example, controllers provide for the association between top-level request handling functionality and the actual web URLs this functionality is mapped to. The controllers directly delegate processing to services. Services, on the other hand, provide actual business logic implementations. They carry out their work in a transactional context. Services delegate to repositories for interactions with persistence functionality. Repositories provide the front end to interactions with the database. Such interactions are carried out by employing the use of Entity Manager, shielding the repositories from directly having to interact with data sources. vFabric Reference Architecture, Topic 14, SpringTrader Mobile. The SpringTrader user interface is dynamic and completely data-driven through ensuring that all communication with the application services are marshaled using JSON. SpringTrader Mobile leverages Backbone.js. The Backbone MVC pattern is embraced throughout SpringTrader in order to ensure consistency. Patterns such as the router pattern through NanoRouter.js, model pattern, and view patterns, including many templates, are actually used. _JS is also used, since Backbone has a dependency on it. Bootstrap provides cross-browser and cross-device compatibility, and jQuery eliminates a lot of cross-browser JavaScript issues, and hence AJAX functionality can be easily added to the application. Specifically in SpringTrader, the following several jQuery plugins along with core libraries are used: Cookie Manager, Plotting Tool, JSON plugin, unit testing, server response simulator, and date manipulation. vFabric Reference Architecture, Topic 15, Modern Enterprise Service Orchestration. Modern service enterprise orchestration can be built by leveraging service creation patterns within Spring, service mediation patterns within Spring Integration, and messaging patterns within RabbitMQ to build reliable and scalable messaging. Also, security and governance can be implemented using Spring Security. Thank you for listening to the vFabric Reference Architecture Overview. For further detail, please visit the below URL.